Okay. And we should be live now. Okay. Okay. So can you guys hear me? Can you type something in the chat to make sure I'm live? Okay, cool. Okay, let me post on Twitter to make sure everybody has the link. All right, cool. So how's everybody doing today? Sound is clear, thank Michael. Hey Nico, how are you? We've been chatting a lot on Twitter. All right, cool. So this is a live stream. So apparently we have something around 10 seconds of delay. But I think probably we should start. I'm good. Thanks, guys. Maybe let's wait like a few more minutes for everybody to join. So where are you guys from? In which country are you right now? Nigeria, Cameroon, Nigeria. Whoa, a lot of people from Nigeria. South Africa, Kenya. All right. Whoa, Nigeria is well represented today. Ghana, Uganda, Togo. All right. Ethiopia. Cool. So all of you are like working on pointers right now, or which cohort are you in right now? Wow, so many people from Nigeria, Tanzania. Cool. All right, cohort 9, cohort 10, pointers, huh? Erase pointers and strings. Cohort 8, nice. Oh, Mustafa, you're about to start in 2 weeks. That's cool. You're gonna have fun. Okay, pointers. Cohort 6, cool, Frank. One of the first. Hey, Alex, how are you? Okay. All right. So maybe we should start. It's like 9:06. This session, I don't think this session is going to be recorded because I'm going to go through tasks. And I don't want everybody to like just go back to the video and copy everything. Actually, this is one of the topic, like I want to address, because I've been gathering like a lot of feedback in the last few weeks. And one of this feedback is that I've heard constantly is like, should I look online for the solution when I'm stuck? I want to get to my 80%. This is the most important thing in my life, like to get to the next project with 80% and things like that. And like people, like when they put like the wrong pressure on themselves, like they tend to go online and just like copy everything. The problem with that is that you're not learning anything. So you're going like from project to project without gathering the necessary information that you're gonna need to actually like solve the next project, right? So one of the things you want to absolutely not do is to go online and just copy, like without thinking about it, like the code that you see, right? This is super important. And what's very important is that you are not here to have 80%. So the score is just like some kind of, information for us and for you to understand where you stand and where you should stand. All right. But this is not, the goal of the program is not for you to have 80%, right? You don't care like the percentage you have. Like the goal of the program is for you, like in a year and a half, to have a good job in computer science. Preferably, right? Or something in tech, like, but using this background, like everything you've learned, to get to a better job, to get to a better position, right? So this is the goal of the program. The goal is not to get to 80%. Nobody's going to ask you, hey, like, what was your score at Holberton when you get there and you are interviewed, right? Doesn't make sense? So don't put too much pressure on yourself. You have to put like a little bit of pressure, right? We're here to do hard things. This is like the mantra of ALX and Fred. And this is like 100% true. We're here to do hard things. This program is not easy, but you know that, right? Getting into the program, it's not going to be easy. And everybody's like, oh yeah, it's not easy. It's fine. But then you actually, hit a wall, and then like, what do you do? But like 100%, you should not cheat. You should not get like the code of someone else online, because if you start doing this, then you're going to do it more often. And then you're going to get into a path that is not the right one. You're going to get the 80%, but you're not going to get the job. So it's like this 80% is worth nothing. So don't focus on the 80%. Focus on you learning, right? One of the things that also sometimes pushes people to cheat is that they see other people like, finishing the projects is like, like 2 hours, and you're stuck for 8 hours on the same task, like the second task of the day. It's very hard. It's very hard on your mind, right? It's like, oh wow, like everybody's finished, I'm the last one. No. So first of all, a lot of people who are not finished, you don't know about it. There's like tens of thousands of people in like the last cohorts, tens of thousands of them who are just like struggling as you are. Same level, right? So what you hear is only the people who finished most of the time, because they want to help. So they say, hey, I'm done. Like, can I help you? This is great, right? And you should be happy for them. Great. Like they finished, they got it, and maybe they can help me, and they're offering help. It's great. It should not be taken as a negative impact on your mindset or on your moods because someone has finished before you. There's always going to be someone better than you. There's always going to be someone with a higher IQ. There's always going to be someone who has done this for 10 years and now it's too easy for them and it's very hard for you. Doesn't matter. You're not here for the others. You're here to help other people, right? But by doing so, you're also helping yourself. You're here to be better than yourself, not better than everyone else. You're here for you to have a job. You're not here to be the best of the best of the best of the cohort. It doesn't matter. Whether you're the first, the second, the third, the thousandth, it doesn't matter as long as you have a job. The goal is to have a job. The goal is not to have 80%. Okay, 80% is just for us a way to understand where we stand in the program and where you stand in the program. Okay, does it make sense? Very, 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 very important. So don't compare yourself to other people. It doesn't matter. Okay, but still, it's natural. Right? And so you're going to compare yourself to other people. But let me show you like something. This is going to be the first whiteboard session. So I think you should be seeing my screen right now, it says Miro, right? And up, switch. So let me show you something. So this is going to be a graph, right? Of, oops. This is the level. Whoa. Okay. And right now, you think you're somewhere here, this level. And then you have someone in your cohort, like, it's he or she is 10 times better than you. If they finish the project in like 2 hours and you're still stuck, you like still haven't done 50%, it's the end of the day, it's like, 10 p.m., like, the deadline is in 2 hours, you're in full panic. And, those guys are like so higher. And then you look at this gap, right? And this gap is huge. And you say, program's not for me. Like, look at those guys. They succeed like so well. But what's the reality? Like, you take a step back. And now you're going to add me in my level to your graph. Okay? And this is the level still. And this is you, and this is me, right? Huge gap. But now you're gonna take the person who's very, very good. Probably, this person is right here, right? So now, like, this gap that you thought were so huge because you compare yourself to the next person, this gap is actually very small. Very, very small. Right? And so now you can say, okay, like those person would have done it in 2 hours, but like Julien would have done it in 5 minutes. So like, I'm not that far in the, in this level set. And then you add Guillaume. So Guillaume, is our CTO, is a great friend of mine, and is much better than me, right? And so you add Guillaume into, the comparison table that you have in your head. And, you are here, and Guillaume is here. And I am somewhere, in the middle. And the person of the cohort who's like the best is probably like somewhere here. And really the gap between you and them is so, so small. So, so small, right? And now you're going to add another person. You're going to add Linus Torvald. This guy is like super, super high, is like one of the best level in the world, right? He invented Linux. He's like a great coder. And, you're probably somewhere here, You just started. And, Guillaume's probably somewhere here. And I'm somewhere here, right next to you guys. And the person who's the best in the cohort is probably somewhere here. You don't even distinguish anything, right? So now like the gap really is this, because your goal is to get there. Your goal is not to get there. Your goal is to get to my level, and then Guillaume's level, and then Linus' level. This is the path you have to walk. And it doesn't matter if someone's like just like one step ahead. This is the huge mountain, and you're gonna climb it one step at a time. You can't run it. You can't run like the entire mountain. Not possible. Sometimes you're gonna run, sometimes you're gonna walk. Most of the time it's just like one step after the other, right? And so when you compare yourself to other people in the cohort, I want you to remind, this graph. The goal is not to get there, the goal is to get here. And so really, you guys have the same level, honestly. Does it make sense? So now the real comparison you want to do, and you absolutely want to do this, every single week, is this is me, day 0, and where do I stand compared to me, day 0 right now? And probably you're here, week 1, week 10, week 15, and sometimes, week 16, week 17, you don't grow too much, and then, something, clicks, and boom, you're going back on the path of growth. So compare yourself only with yourself, like in the past, not with anybody else. It doesn't matter. This is not a race. We've been learning that, you need to be number 1 all the time. It's not true. It doesn't matter. This is not the Olympics. The Olympics, there's only 1 gold medal. Here there's like hundreds of thousands of jobs around the world who are waiting for you. And so it doesn't matter who's the best in the cohort. And, most of the time, the person who's the best in the cohort is not necessarily going to be the best, outside of the program. So it doesn't matter where you stand compared to other people. What matters is that you're moving forward every day, you're showing up. First showing up is like 80% of the job. You know that, right? Most of the people are not even in the program right now. Most of the people are like, watching videos online on YouTube like all day long in their sofa when they have, free time. And you are here grinding and learning, and this is how you change your life. Okay? So you already did the biggest step. The biggest step is to start. Now you have to do the second step, huge, which is like you need to continue, right? No matter what happens. If it's hard, it's good. If it's too easy, then you're learning nothing, right? Think about it. If it was too easy, you wouldn't need this program, right? And so everybody needs this program probably today. Otherwise, you would have a job already, right? So same thing when you compare yourself to other people, like, if they were good enough, they would probably not be in the program. So like everybody's like learning from that, and everybody can learn from anybody, okay? So for those who are like, going through this like very, very quickly, I strongly encourage you to help other people. Never give them the answer, but give them some advice, like ask them questions so that they can move forward. And understand that it's harder for some people than it is for others. And it doesn't, this is life, right? Life is not fair. Get over it. Not everybody has the same IQ. Not everybody has the same experience. Not everybody has, the same environment. Like some people like have noise all the time around them. It's very hard to focus. Some people have, very bad connection, internet connection. It's very hard for them to focus too. Like it's very, it's much harder for a lot more people than you guys. So if you're here in the program, this is like something where, it's going to be hard. It's going to be hard for other people. If you have like free time at one point because, it's too easy for you, that's great. Help other people. By doing so, you're going to, create like a good network. You're going to help other people. And you're going to help yourself, because once you have to explain to somebody, you have to be at a much higher level than where you are when you only solve the problem. This is very true. Every time I teach you guys, every time I do a live coding session, I learn something. Because you're going to ask questions that I have never heard of. I didn't think about it. So, it helps everybody. And, beyond just the coding, right? You're gonna, create links, with each other. And one of the very important thing and like the very powerful thing that, ALX and this program is bringing on the table is this huge network. Can you guys imagine, like, you should be like on LinkedIn adding like everybody, so that you keep the connection. But the people you're going to keep the most connection with is the one you're going to be helping, the one you're going to be interacting with, the one you're going to be brainstorming with, and this is going to be your first circle. And every time I have a problem today, I can't solve everything. I'm not a genius, but I have a lot of people. I helped a lot of people, and I maintain a network, professional network, and a lot of friendship in between. And so whenever I have a problem, I just call somebody who's better than me and at this task. It could be like specific in tech. It could be like, I need to build like this type of program. I know nothing about it. I never done it before. I'm gonna read a lot, and then when I grasp the topic, I have like most of the time a lot of questions, and then I just call my friends. I just call my network and say, hey, I know you did this before. How did you do it? How did you overcome that? Blah 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 blah. Right? So it's not just about coding, right? It's also about building a network, and you are so lucky to be like, like the cohort is so big. Like, like go right now on Slack, exchange all your LinkedIn information, and add everybody to your LinkedIn account. Because trust me, tomorrow you're gonna need each other. And if you maintain this network, I'm gonna hiring you like 10 times more than somebody who doesn't have a network. Because you bring like all this experience with you. It's not just with you, it's with your network. So by nurturing all the nodes in your network, by helping each other, you also building your profile. And this is like super important in the professional life. Anyway, I think I'm digressing a little bit, but I want to make sure, like, going back to the topic, you want to compare yourself only to yourself. You want to compare yourself now only to yourself before, and like maybe setting up a goal for yourself in the future. But don't compare yourself to other people. Like, naturally you're gonna do it anyway. But it, again, it doesn't matter. Like, put things in perspective. Whenever you have a problem, most of the time it's a small problem. But if you only think about it, like in a very narrow fashion, then you think the problem is too big. So take a step back and like think about the big picture. Where do you want to go? Where do you want to be? And like, yes, it's a lot of small steps. Yes, it's going to be hard. This program is tough. This is like, I haven't seen a program that is as hard as this one. And, we've designed it so that it is like this, right? A lot of the things right now you can find on the internet, like tasks are like too easy. They give you the answer because they don't want you to be frustrated, and they want you to stay and then like, feel like a winner. But the problem is like, you don't learn anything. Learning comes from struggling a little bit, at least, right? And the more you struggle, the more you're going to memorize and understand once you get it. And so it's struggling is part of the process. It might not sound like really cool, but struggling is part of the process of learning. If you make everything too easy, you're not going to learn anything. All right? Okay. Does anybody have any question about everything I just said? Is it okay if you don't finish every single task? Yes, yeah, of course it's okay. So I'd rather have you guys finish, 75% of the task and understand all of them, even 50%, but understand all of them, versus like, finishing everything all the time. Again, put this question into perspective. What's your goal? Your goal is to understand what you're doing and to learn from it, right? The goal is not to finish tasks. The goal is not to attend ALX. The goal is not to get 80%. The goal is for you to find a good job, right? ALX is like probably one of the best tools to get to this goal, right? But again, the goal is not to finish all the tasks. The goal is to find a job. So what is the best? Do you think it's within this context, do you think it's better to finish 50% on your own without copying anything, but understanding everything, versus like finishing all the tasks but don't understand anything, right? Makes sense, I think. Yeah, everything's perspective. I don't know who David Malan is. Joshua, what do you mean, how can you participate in the live coding sessions? You want to do live coding sessions too? Emanuela, yes, it's great. If you struggle, you learn. How far gone are we into the live video? I don't know, I have like plenty of time. I'll be there until like you guys go to sleep. Oh, so if you, oh, you mean like, oh, so Joshua, you mean like if you want to, if you want to follow, so like, like follow me on YouTube, follow me on LinkedIn. I have like, right here, there's my Twitter handle, and every time I'll go online, I'll tweet something. Christian, you struggle with problem solving a lot. Yeah, I'm gonna go through a few tasks on the pointers project, the first one, and then you're gonna go through like step by step. But any question on like what I just said? No, the live session is not gonna be available after I finish, because again, I'm gonna go through some task, and I don't want anybody to copy. So Vic, if you have problems, you should have access to the Slack channel. So you should start there to ask questions, and the team is going to help you. So Vinci J, yes, in the case where one isn't able to come up with a solution to a problem immediately, does that get better over time? Yes, yeah, and you're gonna see like they all like there is a framework on like how to go about a task, and the more you follow this, the easier it's going to be. It's just like training a muscle. So like, the chat goes super fast. I can't read everything. Uh, for complete beginners, I think you follow the tasks. Like there is an order. You start with the small thing, and then you add them up over time. Yeah, that's high scrap me rated to pointers. It's not. C is really unfriendly. Nah, that's not true. C is like your best friend, honestly, because like compared to other programs, what we call higher level programs, C doesn't do anything for you, but it doesn't hide anything from you either, right? So you have to understand everything, and it's going to do only what you tell them to do. So it's actually your best friend, and that's my by far my favorite programming language, because I control everything. I understand everything that's happening. In other programming languages, you don't control everything. They take care of like too many things for you. Yeah, but like there are like those programs you can these other programs that take care of a lot of things for you. Like you can build like much faster, cooler applications. Winston, I'm not going to go through the crack me now because this is an advanced task. I just want to make sure that first everybody gets the basis of the pointer. That's going to be the second part of the session. C is like philosophy of programming. Maybe, I don't know. Yeah, syntax is, like C is also like the first programming language that you also are learning, right? So it's going to be the hardest because like all the principle of programming you're gonna learn through C, right? But you're gonna see when you start Python, it's gonna sound so easy. Yeah, Emmanuel, like just like follow me on LinkedIn. If you don't want to miss a session, like follow the channel on YouTube, and every time I'm gonna go live, then like you're gonna be pinged. Can beginners join the live sessions? Yeah, everybody's welcome. It's Taiwo, it's gonna get better, but you have to stick to it. All right. So maybe we go through a task. So the first thing about task, guys, is that most of the time, you have resources to read, right? And for this one, there are like those two things that you need to read. This is important that you read this one for pointers, and step by step. And, I would encourage you to do all the examples. You type them and you try to understand them. And you do it step by step, right? But, one of the things that I've asked on Twitter, a few days ago was like, did you guys have access to a file looking like this one that is not loading right now? Like this one, right? And like almost everybody said no. And I was like, oh, did I forget to add it to the curriculum? That's strange. And then this morning, I had a tweet telling me, hey, but like, oh yes, we do have access to this file. This is part of the concept page. And I checked, and it is part of the concept page. So you really want to read like everything we tell you to read, or most of it, right? But like whenever it's a page on the intranet, you really want to read everything. It's very important. And through the end, so that you can find, like tools like this, for instance. I don't know why it's not loading right now, but we'll get back to it. Anyway, so pointers. So let's go through this example together, okay? Yeah, so for those who have not, like for those who just started, you have not gotten into this problem set, you don't have to stay, but maybe you're gonna learn some stuff by just like looking at how we solve this together. So I would encourage you to stay, but like it's, like this session is not mandatory. So, like if you don't find value in it, just please leave, and, I don't want to waste your time. Okay, so, all right. So this is the first task that you should have had, right? So let's go through it. Write a function that takes a pointer to an integer as a parameter and updates the value it points to 98. Okay, so let's go through this code together. So, do I have my... Okay. So you're here. So like, like it goes this way. So first of all, you declare a variable named n of type integer. Okay? Can anyone tell me how much size it's going to take in memory? How many bytes does an integer take in memory? Anyone? Nobody? Four. Is it always the case? Yeah, I can try to zoom in. Four bytes, yeah. But like, is it always the case? Whoops, it's probably too much now. It's not clear enough. What is not clear enough? Okay, it's four bytes, right? So it's 4 bytes because, but it depends on the machine you're in, right? On a 64 bits machine, it's going to be 4 bytes. On a different machine, it might be different. Yes, Emmanuel, exactly. Okay, so somewhere in the memory, you know, you're going to have like this variable stored. And it's going to take 4 bytes in memory, okay? So here we're going to say, oh wow, my computer is actually dying right now. I don't know if I'm going to be able to use the file. Come on. No. How do I merge the cells? Here. So this is the variable n, right? And at this point, what is the value of n when we declare it? Can someone tell me what is the value of n before we assign 402 to it? The screen view isn't clear. Oh, it's blur. It's blurry. Ay, ay, ay. I'm gonna try to zoom in a little bit, but it's probably my the audio is breaking too. It's lagging. Yeah, I can't fix that, unfortunately. Was it better before? Did it just change or? Okay, so some people are telling me 4 bytes, null, 0. 0, unknown. Yeah, so at this point of the program, the value is unknown. It is whatever is at the memory when the computer places n into this memory address. We don't know what it is. It might be 0, it might be 98, it might be like something different, but we don't know what it is. We have no idea. It's not null. It's not 0. It might be 0, it might be null, it might be like something different, but you don't know. You cannot assume anything about the value of n at this point. So then we go into n equals 402. So at this point, here, we're going to have the value 402. And now, so now n equals 402 because at the address where n is placed, at the address 50, the value stored is 402. And because n is an integer, it takes 4 bytes into memory. So this 402 is actually written through those like memory addresses from 50 to 53. Make sense? So now if I get back to here, then I'm going to print, and then n should be equals to 402 when I print it, right? And then I'm going to use this function, and I'm going to call it with the address of n. And then the goal is to set it to 98. And then when I return from the function, then I'm going to print this and again, and then the value should be 98. That's the goal of writing this function. Okay? Okay. So now we're going to create this file and we're going to start coding. All right. Emacs set up. So let me switch to my terminal. Okay, so here you should see my terminal now, right? For the question before, like what was the value of n? N, you know, like someone says n has no value. It had a value, but it's just unknown. You don't know it. Yes, Sholaja. How did I come up with the value 50? This is just like a random number. It could be anywhere. You don't know about, this is the address, right? I just took a random number and like you should assume that the machine is gonna, you know, use a random number. It's not that random, but you don't know the address. And it doesn't matter. It's just like to give us some examples after that. I just need a value to like go through it step by step. Okay? All right, so you should see like the main file. So I just copied the main file, but I just want to start with like another function. I want to start with just like passing n to my function, just to make sure everybody understands how everything works. And so now I'm gonna, write my reset function, and instead of passing it a pointer to an integer, I'm gonna go and pass it just an integer, just to make sure everybody understands, you know, what we're doing right now. So now if I do n equals 98, and then I go back to my main function, reset to 98, I just pass the variable n here. Okay. Not seeing any 50. Seems the video is different from the audio. No, this was from the question from the 50. For the 50 was about here. When we took the example of n is here, we place it randomly in the memory, and you see I put it at the address 50. And this is just random. I could have placed it anywhere in my file, okay? It's a good question, but just want to make sure everybody understand that this was a, you know, me picking like a random address, just like the computer would be doing. Okay? So we had, when we declared the integer, n was placed into memory. Because it's an integer on a 64-bit machine, then it takes 4 bytes into memory. I placed it like randomly somewhere. I said, okay, it's gonna be here. And then we assigned the value 402 to this variable. And so 402 will be placed at where the variable is. And since the variable is starting at 50 and takes 4 bytes, it goes through the address 50 to 53. And that's where the number 402 you know, is written. Okay, so now the other thing that I'm saying is that instead of passing the address, I'm gonna pass n, not the address, just to make sure everybody understands why we have to pass the address. Okay, so I'm not solving the exercise. I'm making sure that we understand why we go through this exercise and why we use the pointer to be able to change the value of n. Okay. So let me go back to the terminal. So here I'm instead of passing the address of n, reset to 98, I'm passing n. Okay? So I'm just gonna change main.h to say I'm passing an n. So this is the new prototype. And now when I am going to compile, it says parameter and sets but not used. Of course, it's not working. So we're just gonna remove that. So it should be a warning. So it should be set. Okay. So now let's go back. So I'm passing n here to my reset function. Okay. And I have n here, right here. I say, okay, n equals 98, and then I finish. And then when I print f, when I print n again, then what I see is that it's still 402. Okay, so what's happening right now? What's happening is that here, when I call a function, I'm not passing the variable itself. I'm passing the value of this variable. What do you mean, Team Vim? Get out of here, Guillaume. So I'm passing the value of n, not n. Okay? So what does it mean in memory? I'm going to have a new variable called n of type integer inside this function. Okay? So in the memory, going back to my browser, in the memory now, somewhere else, I have another variable called n of type integer. I'm going to place it randomly, doesn't matter where it is. But let's just say it's at the address 68, right? So this is n from reset function. This is n from the main function, okay? And at this stage, when I declare it, what is the value of n? When I'm here, before I assign it 98, what's the value of n at the very beginning of the function reset to 98? Anyone? Yes, it's 402. Why? Because I passed the value of n. And so at the same time, because I passed the value of n, even if it's not the same n, okay, now like this is 42. This is 402. Okay? So n at the very beginning of the function, before I assign it any value, is 402 because I called this function with the value. So reset to 98 is going to receive the value 402 and put it and save it into n. Okay, sounds good. And then I say n equals 98. So what happens? N equals 98 now. So the n from my reset function is now 98. Okay, then I exit my function. So in the memory, like I free all the variable that I created. So this doesn't exist anymore. Poof. Okay, but the value here is still 98, by the way. But there is no variable attached to it. So next time I'm going to declare a variable, maybe it's going to be like int a, and I'm going to put it here, and the value is going to be 98, completely random, because it was used before. So that's why you should never assume what is the value of a variable when you declare it without assigning any value to it. Going back to our example, I exit my function reset to 98. The n from this function is destroyed, right? And so I'm going back to my main function. And as you can see, we haven't changed the value of n from the main function. Okay? So when I print it now again, here, n is still 402. And so that's why I have 402 twice. Any question about this? No question? Okay. So now how do I change the value of the variable n from outside the function where it was declared? I'm going to use a pointer. And how does it going to work now? I'm going to take the address of n. I'm going to change now this to a pointer to an integer, right? And I'm going to also change the prototype to make sure everything works together. So now, like, how is it working? I declare my variable n. And so into memory now I have 4 bytes reserved for this variable. The value is unknown. Then I assign 402 to n. I print the value of n, and you're going to print 402. Now I'm going to call my reset to 98 function. But before I call it, let's go back to my memory to see where we are. So I have n, main, it's 402. Right? And I have nothing else. Now I'm assigning, let me switch to my terminal. Now I'm going to pass the address of n and assign it to a variable called n of type pointer to an integer. So I need to reserve space for this. So this is a pointer to an integer. What's the size of n from the reset function in memory? How much space does this variable of type pointer to an integer take in memory? Anyone? Okay, Joseph is saying 8. Eight bytes, precious. Okay. 4 bytes. 8 bytes. 8 bytes. 8. Yeah, it's 8. Why is it 8? Yeah, it's 8 bytes on a 64-bit machine. All right. Okay. So this new variable of type pointer to an integer is taking 8 bytes in memory. So somewhere in memory, I'm going to put it like, randomly somewhere. I'm going to put it address 20, right? 8 bytes are reserved for n from the reset function. Okay? At this point, what is the value of n from the reset function? At this point, what is the value of n from the reset function? Yeah, Precious, the value is going to be an address, but in this specific example, what is it going to be? No, it's not going to be 98. What did we pass to reset to 98 from the main function? We passed the memory location of n in the main, yes, learn with Max. We passed the memory location of n from the main function. What is in our specific example, what is this value? 98 is not the value. What is the address of n in this specific example? Yes, it is. Yes, Tommy, it's 50. So in this specific example, because n in my example is at the address 50, right? This is going to be 50. We passed the address of n from the main function. So now this is 50. This is the value of n in the reset function, 50. Okay? Again, like 50 is an example, and it could be like anything, right? But it is the address of n. That's what we passed to our function. So this is the address of n. Okay? And the address of n is 50. Okay? Everybody gets it? So it's not Sholaja, it's not 50 to 53. What is passed is the value of the memory address of the first byte. So you don't pass everything. You just pass the address of the first byte. Like mains at the end starts at this address. So it needs to point to the beginning of the 4-byte sequence. Because the computer is going to know that because this is of type pointer to an int, wherever it's going to point is going to be 4 bytes long because it points to an int. So the address is an address of an integer on a 64-bit machine, 4 bytes. It just needs the first byte of the address. The address of the first byte, sorry. Sounds good? Okay. So from there, now we want to modify n. That's the goal. Let me go back to my terminal. And so can I do n equals 98 in this context now? Joseph says no. Learn with Max says no. Yeah, so why can't I do that? Maybe I can. I'm pretty sure I can do that. It's not exactly what we want though, right? But can I like put 98 into n? You know, what happens if I do that? If I do this, then I put 98 here. Then I lose the address of n, so I'm never going to be able to change n again, right? If I do this. What we want to do is not changing this value, we want to change this value. Okay? So the way to go, like the superpower of the pointer, a pointer is just like, you know, a number, which is like it stores a number, which is the address of the variable it points to, but you can use a pointer to go to this address and change the value that is stored at this address. Okay? So now if we do this, it means that we go at the address of the value n and we store this value. And so it means that we go at the address stored in n. So n is 50. We go at the address 50, and here we're going to put 98. Okay? So now that I've done that, I'm going to exit my function. This variable is going to be deleted, right? I'm going to free the memory to be used by, you know, another function if we want to. But then I'm going back to my main function. And now when I print n again from the main function, it is 98. And so now, if I compile it again, it should print 402 and then 98. Any question about this? You can change the value stored at the address, not the value of the address. Okay? You're not seeing the terminal. Yes. Sorry, my bad. So now when I compile again and you know, and run it, it works. Do you guys understand everything about, you know, like this is the most basic concept about pointers, and pointers in general are like something like a little bit hard to understand at first, because this is very abstract. You don't see anything, and that's why like using like this type of file, of Excel file that I'm using, to go like step by step through the example is going to really help you understand how everything works and why we're using pointers. The terminal is the black window where I type all my instructions. Anyone, any question? No, like Kedishi, like this is the right time to ask question. Like asking question is part of the process. If you don't ask the questions, then you're gonna pile up all the misunderstanding. So please, like, ask your questions now. There's no bad questions. There's no wrong questions. Like, what's wrong is having a question and not asking this question. So please go ahead. I'm waiting for a question. Okay, Flick, you did not understand. All right, fair enough. But what exactly is your question? You want me to run everything again? Yeah, okay, I can do that. So let's do everything again. Like the last example, right? So like everything around pointers, only if you have started C already, learn basics. If you have not, then it's gonna come later. Can you get the Excel file? Yes, I'm gonna tweet it right now, okay? And then you can copy and use it. Can I tweet it? Can I? Oh no, I can message it here. Can you see it? Does it work? No, the session is not recorded because I don't want anybody to copy. Okay, let me tweet it, and you can just go and grab it because okay, I just tweeted it, so you should be able to access it and copy it and then use it. With Chelsea instead of C. Question is everything on pointer, but so Kedishi, you can't have like a question everything on pointer. It doesn't work, right? You have to ask specific question. I'm happy to rerun everything. So let's rerun this one like a little bit faster, and then we can go to the second task, okay? And then we're gonna see the exact same concepts. So let's rerun this one from the beginning. Okay. So I'm gonna reset everything. I should do this or not? Okay. So I'm having my function. So a program starts with the main function, right? So now I'm declaring an integer that I call n. And so in memory, somewhere, random, I'm gonna have an n stored somewhere. Because it's a type integer on a 64-bit machine, it's gonna take 4 bytes. At this point, though, we don't know what the value of n is. It is unknown. Okay? Now, I'm assigning the value 402 to n. So that means that in memory, where n is stored, on those 4 bytes, I'm going to store the value 402. Okay? Now I'm going to print it. So on the screen, you're going to see, n equals 402. Then I'm calling my function reset to 98 by calling it with a pointer, the address of n, right? I'm calling it with the address of n. And this is my function. I'm going to store it in a variable called n. I can call it like whatever I want, right? It could be a. It could be like p, like pointers, if we want to. It doesn't have to be the same name as the other variable, just making sure everybody understands that, right? So let's just say now it's called p. So I'm going to store in a variable p of type integer, of type pointer to an integer in memory somewhere, the value of the address of n. Okay? So somewhere in memory, I have p. I don't know where it is. Let's just say it's right here. because it's on a 64-bit machine, it's a pointer, so it's going to take 8 bytes. This is P, and the address right now, right away, is the value of the address of N. Okay? The value of the address of N is, in my example, 30. So here, I'm assigning to P the value of the address of N, which is 30, right? Here starts my variable N. It's at 30. Take 30, 31, 32, 33, 4 bytes on a 64-bit machine, right? But you only, like when you say the address of a variable, you take the address of the first byte of this variable, okay? So in P, now I have 30. Going back to my code. In P, I have 30 at this point. Now I assign 98 to, I'm going to write 98 to the address that is stored in P. So P has a value. I dereference it to get to this address. Since P, in my example, is 30, I'm going to go and write 98 in the address starting at 30. So I'm going to write right here 98. Okay? Now going back to my terminal. Now I exit the function resets to 98. So I free all the space that I used in memory specifically for this function. So my variable P is going to be freed. So it's not going to be there anymore. What is stored in memory is stored in memory. It's not going to change. But then I don't have like P anymore. I can't use P anymore. Okay? So then my memory looks like this. I don't have P anymore. The value is still here. But N has been changed, right? Thanks to the pointer. So when I go back to my function main, and now I print the value of N, it has been changed to 98. So now I'm going to print 98. Okay? Does it make sense? Joseph, you laughing? Is it a good sign or a bad sign? Any question? Should I go to the second task to just check another example of how you deal with pointers? Vivian, it's not that I can't see your questions because everything goes like super fast. What is your question? Oh, explain the reset function again, please. I just did it. Is it better now? Run the code. You want me to run the code? Yeah, no problem. So I'm going to compile it and run the code now. Make sense? Very clear, good. Why did P disappear? So because P is a variable that is local to the function reset to 98, when it is created when you call the function, but when the function ends and when you exit the function or you return the function, then everything that was used by this function is freed into memory. Right? So that somebody else, like another function or the program can use this memory for something else because you're not using the function anymore. So it doesn't need P. Does it make sense? You have to change address of n to address of p. No, Joseph. So look, here, my variable here is n. So I give it the address of n. Right? Here it's not called p. The way I access the value 402, what was stored in n, is by, getting the address of n. And it doesn't matter what is the name here. It's another variable in another scope. Okay. How does all this file work together? So when you compile, here, you're using the compiler called GCC, like there are like flags here. I'm not going to get into the detail right now, but like you see, like I have my main function and my reset function, so that I use both of them to create the program called like 0-98. That's how they work together. You should have learned that already, right? If you're in cohort 9 or before. So why did n print 402 twice initially? Oh, okay. So initially, what I did was I didn't pass the address of n, I passed n. Just to make sure you understand why we're using a pointer and not just, not just passing n. If you do that, I'm just gonna go through this example again. If you do this, sorry. If you do this, then n here is 402. So when you print it, it's 402. Then you call reset to 98, not with the address of n, but with the value of n. Right? So you pass the value of n, you store it into a variable called p, then you change the value of p, and then you destroy p. You have done nothing to change the value of n from the main function, right? So let me go through again, like the memory, what happens in memory. So you have n, it's 402, then you call another function with the value of n, with 402, and you store it into another integer, right? That in our example is p, right? You call it with 402, the value of n, instead of calling it with the address of n. So here, this is 402, right? And now you say, okay, p equals 98. You change p, that's great. Then you exit the reset function. P does not exist anymore. You're going back to the main function, and n is still 402. That's why. Does it make sense, Vivian? In this example, like this is like what I started with first, like for those who are joining us, just to make sure that you understand why we are using the pointer in that example to change n. You can't change n if you don't pass the pointer. Why do we have to use prototypes? It's a good question. Like you have to use prototypes because otherwise the compiler is going to guess what are the types of, what is the return value of the function, what's the type of the function. And you don't want that. You want to make sure that, so the doc you tweeted needs access. You don't have access to it? How do I do that? General access. Anyone with the link. Done. Okay, this should be fixed now. The freeing that happens in the reset function, explain it a bit, please. Okay. So, whenever whenever you're calling a function, this function needs like space in memory to work. In our example, it needs to store the variable p of type integer, right? So it takes memory, right? And then you have like a limited amount of memory. So you want to free like as much memory as you can to make sure that your program is never going to run out of memory. So that's why like when you're not using the function anymore, everything that was used by this function is automatically, in some cases, freed by the computer. And you're gonna see like later on, for those who have just started, see that, you know, like right now everything's taken care of by the computer, but then when you're going to use malloc and free, you're gonna have to take care of that piece of memory yourself. And that's gonna be like really fun. Okay, but if you print p in the reset function passing the value of n from main function and changing it to 98, it will print 98 just before exiting that scope. Yes, but what are you? 100% true. What is the practical use of a double pointer? So imagine you want to pass a pointer to a function, but you want to change the value of the pointer. You're going to need the address of the pointer to get there to change it. Basically, pointers of a link or a link. Yes, kind of. So the compiler, so I'm not going to get into like super advanced stuff, you know, like virtual memory and compiling stuff. Let's stick to the basics for now, and then, you know, maybe we can think about having like a cool session about playing with the virtual memory later. Okay, let's get to another one. The number 2. Okay. Number 2 was swap integers. Okay, let's do this. I just changed the permission on the file, so now you can access the file. You need to copy it though, because otherwise, if everybody edits it at the same time, I'm not going to be able to do this session. So you need to copy it and then you can edit it. I'm not going to save this live session. I don't want anybody to copy the code. I want you guys to listen, understand, and ask all the questions you need to ask right now to get into this habit of asking questions. If you have any question, you can ask me right now, Lucy, or anyone. Okay, so a function is not a program. A program is a set of functions. Okay, let's try not to digress. All right, let's do swap int. Swap int. Okay, Emacs. What's the name of the file? Name of the file should be one swapc. I tweeted the link. I just tweeted the link on my Twitter, because otherwise you're not gonna see it, because everything goes super fast on the chat. So I just tweeted. Just go on my Twitter account, the last tweet. Okay. So I'm just gonna copy the main file. No, that's swap. And this is one main.c, one-main.c. Copy this. Okay. Paste. Okay. So Let me switch to my terminal now. Okay, before I get into like more advanced tasks, I want everybody to understand like the basic tasks, right? Once you understand the basics of pointers, everything like is much easier. Okay. Okay, PG Tech Media. We can answer this like in the later session. Right now, I just want to make sure like everybody has all the basics. But this is a great question. Okay, let's go through the swap task. So my goal is to swap the value of like two variables by calling a function. Okay, so why do I have to pass the address of those two variables here to make sure that I can change the value of A and B? Because again, if I pass A and B, I'm going to just pass the value of A and the value of B. It's going to create two other variables in my swap functions. I'm going to change the values over there. But then when I get back to main, I haven't changed the values of the local variables. Okay? So let's go like through step by step. So we need the swap function. And the prototype is void swap. Okay. Paste. And now I need to swap A and B, right? So how can I do that? First, let's talk about the memory. What is happening at each step of the program? So the program starts with the main function, right? So here I declare a variable of type A and a variable of type called A and B of type integer. Okay. So what does it look like in my memory? Let's go back here, here. Whoa. Up. So I have a variable of type A. Let's just say it's right here. Of type integer, name A. Since it's an integer, right? It takes 4 bytes in memory on a 64 bits machine. And then another one called B, somewhere else. Up, B, and at this point, can someone tell me what is the value of A and the value of B? Right here. At this point of the program, what are the values of A and B? Anyone? Unknown, yes. Jainam, it is unknown. At this point, it is unknown. Okay, it is not set yet. It is unknown, yes. Okay, great. So then I'm going to go to this line and then assign 98 to A. So my memory now looks like A is here. And now I'm gonna store 98 where A is stored, right? So now It's going to be 98. Okay? At this point, B is still unknown. Like the value of B is still unknown. But we know that A now stores 98. So the value of A is 98. The value of B at this point is unknown. Then we go to the next line. Now I'm assigning 42 to B. Okay? So in memory now, where B is stored, I have the value 42. Okay? So now, at this stage, we know that A is 98, B is 42, and then now I'm going to print A and B, and so it's going to print 98 and 42. Okay? And now I'm going to call swap int with the address of A and the address of B. Okay? Swap int is a function that takes two pointers to an integer that we call A and B. But again, just to make sure everybody understands, we can call them like whatever we want. Let's call them Y and Z. Okay? So Y is going to be a pointer to an integer. On a 64-bit machine, it's going to take 8 bytes in memory. Same for Z. Okay? So swap int is going to need two pointers to integers, right? So let's just say this one is Y and this one is B. What are the values of Y and Z? What are the values of Y and Z at this stage? Joseph, I'm not typing anything in the swap function yet. So in the swap function, I have my two pointers to integers, Y and Z. What are those values? What are their values? The address of A and B, yes, exactly. Omo Wale, you're totally right. No, it's not unknown. These are the addresses of A and B because right away I call the function swap int with swap int has been called right away with the address of A and the address of B. So right away, they have a value right away. Okay? And their value is, yes, 23 and 40. Because 23 is the address where A is stored. So Y is 23. And Z is the address of B, and B is stored at 40. Okay? 23 is where A starts. 40 is where B starts. Okay? So Y contains the address of A, and Z contains the address of B. Okay? The address, once again, the address of A is 23 because that's where it starts, and the address of Z is 40. The value of Z is the address of B because that's where B starts. So 23 and 40. Okay, right away. Okay, so at this point, now we have the address of A and the address of B, and the goal is to swap those two numbers, right? So we want to put 42 here and 98 here, okay? So how are we going to do this? Let's think about it. If I put 42 right away into A, then I'm losing the value of A and I can't put 98 here, right? Because I don't know what was the value of A anymore. Okay, makes sense? So the way to solve this is to store the value of the variable we're gonna replace the number with first somewhere else so that you can use it later. So we're gonna create a variable of the same type. Let's call it, C. Somewhere in memory, we're gonna put the 98 here. That's the goal, okay? Once we have stored the value of A, we can erase it with the value of B. We can copy B into A. And now we're going to take the value stored into C, which was the old value of A, and put it back into B. Okay? That is what we want to do. Make sense? So how do we go about it? Let's go back to the terminal. What do we need? We need a variable of type int that we're going to call C. Okay, at this point, C is unknown. So let's go back to the browser, to the memory. What we've done here is we just declared a variable of type integer called C. The value of C is unknown, right? Makes sense? This is a temporary variable, exactly, Nico. That's the idea. So going back to my terminal, now, what we want to do is we take the value of A. Okay, the value of A is what? How do I get to the value of A from the main function? I can do this with a pointer, right? The value of A is what? As the address stored in Y. Salami, how do you create a new variable? You just declare it this way. So I just created a variable of type int. It happens that in this case, this variable is kind of a temporary variable. It's not a type. Temporary is not a type, Just making sure it's clear for everybody. So now when I do C equals what is at the address stored in Y, this is basically the value of A, right? Why? Because Y contains the address of the variable A. Okay, so what does that mean? It means that C is now you're going to go at the address of stored in Y, which is 23, which is this. And so this basically is exactly the same as this, right? So when you say asterisk Y, you dereference the pointer Y. So you go at the address stored in Y, so you go at 23, you take the value of this, and then you put it into C. So now C equals, in our example, 98. Okay? Going back to the terminal. Now that I have stored the value of A, I can erase it. So now the value of A, I want to get the value of B and store it into A. Okay, this is how we're going to do this. What is this line doing? Let's go back to the memory. Okay, what is this line doing is it is taking the value stored at the address 23. Yeah, this is wrong. If I do this, then it's not gonna work. If I do, let me copy this. Oh no, it's actually working. Copy. So now trying to explain this, okay? So I'm gonna take what is stored at the address Z, right, by dereferencing the pointer Z. So what is stored at 40 is the value 42, right? So I'm taking 42, I'm gonna put it at the address stored in Y. The address stored was 23, so I'm going to put 42 at the address 23. So here I'm going to put 42. Okay? So now what I need to do is I need to put 98 into B. And the way I'm going to do this is that I'm going to take the value of C and put it into B. The way to put it into B from the swap function is by using Z, which contains the address of 40, the address of B, which is 40. So we're going to go like this, basically. What is at the address stored in Z? You're going to put the value of what is stored in C, right? So going back to my terminal, now I'm going to say, okay, Z equals C. So when I do this, now my memory is 98 in B, okay? Because I did this. So I put the value of C and put it into the address stored in Z. I don't put it in Z because otherwise I would put 98 here. I put what is at the address of Z, right? And so then the address stored in Z is 40. So at the address 40, I put 98 because C equals 98. If I do this, I'm going to put 98 into Z, and it's not going to change B, right? So at the end of my function, this is what the memory looks like, okay? So then I'm going to exit my swap function. Everything that was needed for this function to run is going to be freed, right, by the computer. And so C is not going to exist anymore. Z is not going to exist anymore. Y is not going to exist anymore. Those values are probably going to stay in memory, right, until they are reused by another variable or whatever the program needs. And so when I get back to my main function, now A equals 42 and B equals 98. So getting to here, so where's my terminal? Here, okay. So now this should work, I guess. I just need to have the prototype. Nope, it's not this. Do I have the main somewhere? No. It's just the prototype. And now if I compile everything, it should work. So up. Okay, if I run swap at the beginning, A equals 98, B equals 42, and then after I exit my swap function, I have effectively swapped the two variables. Okay, so what are the questions? Why not Z equals C? Oh, it's a good question, Omo Wale. So, question is, why is it this and not Z equals C? So, this, I'm gonna try to explain it to you like by, just going back to the memory template. So memory, what's okay, we're at this point now. If I do z equals c, okay, so first of all, I cannot dereference a variable that is not a pointer. C is of type integer, right? So it's not going to compile. But imagine it compiles. If it would compile, then you put at the address 40, here. What is stored at the address of the value of C? The value of C is 98. If you go to the address by doing this, you're going to the address, right? 98. So you're going to the address 98 and you take whatever the value is here, right? And it might be like completely random, it might be 0. And then you're going to put it into B. You're not going to put 98, you're going to put what is at the address 98 into B. That's why you don't do it this way. Can C equals Z work? It's another question. Is it possible to use putchar? I mean, maybe, but like I don't see why. Why do you want to use putchar, Ezekiel? So can you do C equals Z? You can do C equals Z. So you store in C what is at the value that is stored at the address of Z, which is 40. The value here is 42, but you put 42 into C by doing this. So you haven't changed the value of B. Does it make sense? What is the difference between C and C? Between C and C. So C is a variable of type integer. So you can't dereference it. If it's not a pointer, you can't dereference it. So it's not going to compile, right? But imagine it would compile. C is the value of C. The value of C is 42 right now in this example. Okay, let's do something else. Is 100, right? So C, the value of C is 100. Okay, if you were to dereference C by doing so, then you would go at the address of 100, which is 100, right? And you would take this value. Right now, we don't know what it is. It might be like, I don't know, like 0 or 42, 42. Maybe it's 0. Let's just say it's 0. Or maybe it's just 1. Just say it's 1. So then in this example, it's 1. So the difference is it's big, right? It's like this is the value of the variable itself. And if it was a pointer, you would dereference it and you would get the value that is stored at the memory of the value of C. You would take the value stored at memory 100, at the address 100 in this example, because C equals 100. So it's totally different. Does it make sense? Ulkrayora, sorry, has a good question. Why don't we declare C as a pointer to an integer? It's possible. You can do this with a pointer to an integer. Let's do the same exercise with a pointer to an integer. So the idea here is instead of using an integer to store to store the value, I think it was like 98 and then 42 or 42 and then 98. I don't remember. Doesn't matter. 98 in A, B, 42. It doesn't matter, but text. Okay. It's memory. If you want to use a pointer, you can. So let's just say we declare a pointer like this, which is a pointer to an integer, like to store our temporary value. What we want to store, wait, is it possible? Yeah, you're still gonna need something different. So if you were to do this, you have a variable of type pointer to an integer, right? So it would gonna be C. The value is unknown. And then here you want, normally you want to have the address of something, right? And so what you want to swap is the value of those two integers. You don't want to swap pointers. So actually, like, unless you have another variable that you call, I don't know, CC, or maybe D, or maybe I, that C points to, then you can use like the pointer C to change I and then change A and B, but it's much more complicated and it doesn't make sense to do it this way. So like you really want to use like an integer here. How do I come up with my values? So the values are the ones that are in the example from the project, right? So here, this is my main file. So we assign 98 to A, 42 to B, then we print them and then we swap them. Okay, so that's for the values. And then for the memory addresses, it's just random. You can place them wherever you want and play with that. Any question on the swap function? No? Okay, so do you guys want to do like another one or are we done for tonight? So, okay, another one? All right. Another one. Okay, let's do another one. Okay, what is the next one? Okay, what's the next one? The next one is string length. Is this one you want to do? Or do you want to do another one? Which one do you want to do? Should we do, like, we should do one with a... You want to do the reverse? Like print rev? Reverse function? PG take, don't don't paste like 10 times the same thing. Okay, ref string. No, we're not gonna do the magic. We're not gonna do the crack me. I just want to stay on the pointers for everybody to. Okay. Let's do ref string. What are the others? Like put asleep. Same half. Pointers. All right. Print ref or ref string? Ref string? Okay, let's go ref string. Yeah. Okay, so this is ref string. So you want to print the string in reverse. Great. Let me create my main files. So, let's see. Paste. Okay. And then should be fiber string. Paste up. And prototype. Paste. Okay. Okay, some of you have like a huge lag, like 30 seconds. We're going through rev string right now. So I'm just like setting up the main file and the prototype. Give me a second. And then we're gonna whiteboard it, okay? Because I'm gonna go through a little bit of, so this one is a little bit more advanced. So it's gonna be cool to whiteboard it. Okay. So everything's set up. Let's do a little bit of whiteboarding. You should see my screen. Okay. All right, let's go. So the goal is you get a pointer to a char and you want to print the string. Okay. So how is this going to work? How is this going to work? So in C, what's very important to understand that in C, a string is a collection of what we call a string. First, a string is not a type. Okay? What we call a string is a succession of letters, like the letter H, E, L, L, O, and it always should end with the character \0. Okay, and this is, basically how C knows that this is the end of the string. Okay, so when you have a string like this, for instance, okay, this is actually in memory. This is how it is stored, byte by byte. Okay, one character at a time. In C, one character is encoded into 1 byte. Okay, one character is 1 byte. And the value, and like the computer doesn't store a character, right? The computer in memory, it stores actual value, numbers, only numbers. And so the value of each of those letters can be found in the ASCII table. And that's what is actually stored in memory. Okay? So let's take this example. So I want to have hello. I want to use the string hello in my in my program. Okay, so you're gonna have to store it in the virtual memory so that your program can use it. And let's see the way it is stored again. So let me reset everything to 0. Okay, so somewhere in memory, if I declare somewhere hello, somewhere in memory, randomly, I'm going to choose like a random place in memory, like for instance at the address 50. I'm going to have an H, an E, an L, an L, an O, and at the end, a \0. Okay? But what I said is that actually, hello is not going to be stored this way in memory. Okay, but like it's easier for us to like just use the letters. But this is the string hello, and it takes 6 bytes in memory, right? So 5 letters plus the \0, so 6 bytes. Okay, actually those again, like those characters are not stored as characters. The computer only stores numbers. So the way to know the code, the ASCII code that is stored, you can do man ASCII. And here you're gonna see all the letters and how they are encoded. So where are my letters? So H, capital H, right, is going to be here. So this is the decimal representation of the letter L, H. Okay, so H is 72. So actually, in memory, here you're gonna have 72. Okay, same thing for E. So you go back to the terminal, and then you're gonna look for E. Okay, here, and the value is 101. So here, actually, what is stored is 101. Okay, now who can tell me what is stored here? What is the value that is going to be stored here, right here? Anyone? So Emmanuel is saying 111. Guanier is saying 108. Okay, let's check. So going back to the terminal again, if you don't know by heart, you can type man ASCII. Okay, so the way you encode the letter L, where is it? Oops, I was too fast. It's right here. This column is the one that is going to give you the decimal. So this is 108. Okay? And O is 111. Okay? So going back to the browser, this is 108, this is 108, this is 111. And what is the \0 value? Anyone? What's the value of the backslash 0? 0, yeah. It is 0. So anytime you're gonna hit the value 0 or the character backslash 0, right? It's not null exactly. Null is a little bit different. And you know, we can talk in the later session what are the differences between 0, backslash 0, and null. Because null is like those, like everything has a type, right? Backslash 0 is a type char, 0 is a type integer, and null is a type pointer. So they're all different, but all their values are 0. Okay? So anytime you want to go through a string, you know that it's going to end with the backslash 0 or the value 0. Okay? Again, not null. So if you want to go through this string, if you want to print the string, what you would do is normally you would go through 72, you print this value on the terminal, is going to give you H, and then you go to the next one, 101, the terminal is going to give you E, and then L, O, and then 0 tells you it's the end, and so you stop. Okay? So if you want now, in our example, we want to reverse the string. Okay? So let's go back to the whiteboard. But I just want to make sure that everybody understands, how everything works in memory first. It's always good to start with, how everything works in memory. It takes a little bit more time, but then you can go step by step. Once you understand like the step by step, then everything's gonna click. Null, null is not the same as 0. Yeah, salami. Correct. It's not. Well, we can talk about this, after. Okay, let's finish this, and then otherwise we're gonna digress. It's already like 2 hours of video. Okay, so let's go to the whiteboard. So let me see if I can put it. Just do it or not? Okay. Yeah, move. It's gonna be easier. Okay. So I have my hello. Oh, it's not working? Oh, I don't know, it's not working. Okay, it doesn't matter. Up. I just got the tablet yesterday for this session, so I'm not used to it yet. Okay, so we want to reverse the string hello. Okay. What we know is that it's going to end with the backslash 0. Okay. And the only thing that you're gonna get, right, is a pointer to this string. What does it mean? A pointer to this string is going to be the pointer to the first byte of the string. Just like we talked earlier, it's to be the first byte of it, okay? So you're gonna have the pointer that points to the letter H, basically, okay? What's the pointer? It's the address of that letter, pointer to the string, right? It's the pointer, it's the address. So you're gonna have the address of H, basically. And what we want to do is to basically swap H and the last one, which is O, right? And then you want to go to the next one and swap it to the one that is just before the last one. You want to swap E and L, right? And then it's over because this one is in the middle, so you don't have to swap it, right? So if we take another example, A, B, C, D, E, F, right? You know there's a \0, but essentially what you want to do is that you want to swap A with F. Swap A with F. Then you want to swap B with E. Then you want to swap C with D. And then you want to stop. Okay? So you basically want to swap this letter with this letter first. Okay? So here probably you're gonna need a pointer to this letter and a pointer to this letter, right? Because otherwise you can't swap them. And then you're gonna move one byte in this direction with this pointer and one byte in this direction with this pointer, and then do the same, swap those two letters. Then again, you know, one step on the right with this pointer, one step on the left with this pointer, and then swap those two letters, and then you end. Okay? So here it seems that you're going to need a pointer to the first letter and a pointer to the last letter, right? Then you're going to walk this way with the first pointer, and you're going to go that way with the first pointer, with the second pointer. Okay? So our first task is to get this first pointer and this second pointer. All right? Which is cool is that we're going to get the pointer to the first letter right away, so we don't have anything to do. But we need to find the pointer to the last letter. That's our first task. How do I find the last letter? The way to go, since we only have the pointer to the first letter, is to walk through the string until the last letter. And how do I know this is the last letter? I know it because right after it, there is the \0. Does it make sense? So I'm gonna go here. I'm not, and like, look at what I'm doing. I took several examples and walked through them to make sure I understand what I need to do, right? And then I'm going like small task by small task. My first, goal is to find the pointer to the last letter. I'm not solving everything at once. I'm not solving the ref string right away. I'm solving it on the whiteboard just by drawing. Once I understand what I need, then I'm solving like item by item. Okay? So I'm gonna now go back to my terminal and solve my first item, which is I need to find what the pointer or the address of the last letter to be able to swap them, because this is how I'm going to do it. Okay? But essentially I solve the algorithm before I go to the code, right? I know I'm going to need those two pointers, and then I'm going to swap the letters that they point to, and then I'm going to go this way with one, this way the other, and swap those two letters, and so on until they cross, basically, right? So let's do that. So first step, I want to find my last letter, or like the address of my last letter. And the way I do this is I go through the string, and when I hit the letter which is right before the \0, then I'm there. So let's go to second part. No, here. go to my terminal. Let's go a little bit now. So ref string. So S is pointing to my first letter. Okay. I know that. Now I know I'm going to need another pointer, which is going to point to a character, because we want it to point to the last letter, right? So it's going to be of type pointer to a character, and we can say that this is the, I don't know, the right pointer, like, because it's going to be like on the far right, right? And now I want to walk this pointer through the string until I hit the \0, or until I hit the last character of the string, okay? So where do I start? I start at the address of the first letter, right? I'm not gonna start from like anywhere, like a random address. I'm gonna start from the address that is stored is S, which is the pointer to, which is the address of the first character, right? So I'm gonna do R equals S. Okay, so let's go through what is happening here right now. In memory. So I think this is 5, yeah. So here, I'm in my main function. This is where the program starts, right? And then I declare an array of string of size 10 that is called S, and then I copy this into this new variable, okay? So what's happening really is that somewhere in memory there is this string, but this is called a literal string. You cannot change it. If you try to change this string, it's going to crash. So you have to copy it into like a portion in memory that you can actually change. That's why we're doing this, okay? So when I do this, actually somewhere in my memory, I have my school written somewhere in a memory address that you cannot change, okay? In a special segment, my school. Let's just say it's, let's just imagine it's, no, let's do something completely. So somewhere here, let's just say it's here, I have the variable my school. I have the string literal my school, literal string literal my school. Okay, so it's like mi space s c h o o l and then \0. Again, these characters are not stored in memory, like their ASCII value is stored in memory. But for making sure like it's easier for us to understand, I'm just gonna put here the character, right? But remember, there is no character stored, only the ASCII values of both characters, okay? So now, sorry, I was not on the browser. Boom. Okay. So here at the memory address 120, I have my string literal. How do we know it's literal? It's in between double quotes. That's how we know. Everything that is in double quote that is stored in memory in C, you cannot change it. You can access it by, you can read it, but you cannot change it at all. So you can't reverse this string. This string is irreversible. Okay? So going back to the terminal, here I have declared a variable S, which is an array of 10 characters. One character is 1 byte, so 10 characters is 10 bytes. So S is 10 characters, 10 bytes long. So I'm gonna put it somewhere in memory. Just stay here. 10, up 10 bytes. So this is S, and this is actually S10. Okay, and here right away, I copy this string here. So right away, when I declare it, it is copied into it, okay? So these are the values that are stored in its memory address. So when I print now my string, it's gonna print my school, okay? Now I'm gonna call rev string, and that's when I need to swap things. So going now, calling my string with the value of s. What is the value of s? It's the address of the first character. It's actually not exactly that because this is an array. So this is the address of the first byte of the array, which is 40. Okay? So here when I call ref string with s, I pass the value of s is 40. So here, s, and again, like it could be called like whatever, could be called like PTR, like the pointer. I create a variable PTR which has the value of s, right? So at this stage, when it is called, I have a variable called PTR of type pointer to a char. Okay, since it's a pointer on a 64-bit machine, it's going to take 8 bytes in memory. Okay, so this is PTR. PTR, like pointer, PTR. Take 8 bytes in memory. That's 7. Up. And it takes the value of the address of S. Okay, so that's 40. Okay, so PTR's value is 40. This is the address of the first char of my string that I want to reverse. Okay, so now going back to our algorithm, we said that we first wanted to find the address of the last letter. So we want to find, basically here, we want to get to a variable that contains 48 in our example, right? So I have a pointer that points to my first letter. I need a pointer that points to the last letter. The way to do so is to go through all this string and find the last letter. And we know this is the last letter because right after there's the \0. Okay? So going back to the terminal now. I need a variable of type, where am I? Here. I need a variable of type pointer to a char, right? So at this stage, I declare a variable called r, like right, okay? And this variable is of type pointer to a char. So at this stage, my memory looks like this. I have another variable of type pointer to an integer. So this is going to take 8 bytes in memory. I call it r. And at this stage, the value of r is unknown. I have not assigned any value to r at this stage. Okay? Then I say I want to find the last letter, so I need to start with the first letter and then move towards the end until I hit the last letter. So I want to start at the first letter. The first letter is stored at the address that is stored in PTR. So I'm going to say R is going to take the value of PTR so that I have the address of the first letter so that I can move it to the last letter. Right? This is what we said on the whiteboard. So this is the first step. So at this stage, I put the value of PTR and I store it into R. I can do that because they're both of the same type, right? They're both addresses to a char. So now if I go back to my memory, at this point, I said R equals PTR, PTR equals 40, which is, by the way, the address of the first char. And so now R is 40. Okay? So now I need to move this pointer one step at a time until we get to the last letter. So this sounds like kind of a loop, right? We go one step at a time until we hit the last letter. How do we know this is the last letter? There is like the \0 right after it. Okay, so at the address R plus 1, we're going to find the \0. So as long as at the address R plus 1, the one on the right next to it, is not \0, I'm going to move my pointer to the right. Does it make sense? So while what is stored on the right of at the next address next to R, so R plus 1, right? R plus 1 is an address. You go and check what is at this address. While this is different from \0, then you move R by 1. Or R equals R plus 1. Okay? So what does that code do? Can I paste it here? Yeah. No, swapping the address is not going to be enough to swap the values. Right now, we're going into like step by step what we need to do. The first thing we need to do to be able to swap the values is to find the address of the first letter and find the address of the last letter. Then we're going to swap. But for now, we need the address of the other letter, right? Because otherwise, we're not going to be able to swap them if we don't know where they are. Okay? So like right now, this is the first step, is to find the first and the last the first and the last character by walking through the memory. Okay? So let's go step by step. I have let me see if I can do it something else. Maybe I can snipe it. Just want to make sure everybody sees the code at the same time as we see the memory. Can I do that? Yeah, it works. Okay, up. Let's put it here. Okay, so I have OR. I set it to PTR, right? So now OR points to here, okay? So I'm gonna put it here. OR plus 1, OR plus 1, and OR plus 1. So we're going to go step by step. At the very beginning, the value of OR is 40. Okay? So if I dereference this pointer and I go at the address 40, what is the value? The value is M. Okay? The ASCII value of the letter M. R plus 1, R is 40. R plus 1 is 41. What is at the address 41? Y. Okay? Is it \0? No. So then I'm entering my loop, and then I say R equals R plus 1. So I move my pointer by 1 byte. So now R equals 41. Okay? So now the value stored at 41 is Y, the ASCII value of Y. R plus 1 is 42. 41 plus 1. What is at the address 42? Space. Is it backslash 0? No. So I continue. So now I do r equals r plus 1. r plus 1 equals 42. What is at the address 42? Space. The ASCII value of space. What is the value of r plus 1? 43. What is at the address 43? S. Is it backslash 0? No. So now I do r equals r plus 1. What is where r plus 1 is 43. So now r equals 43. Can you use the for loop? Yes, you can use the for loop. That works too. I can do it like the same way after. I'm gonna give you the same way you use with the for loop if you want to. Then what is stored at the address 43? S, right? What is r plus 1? 44. What is stored at the address 44? C. Okay, and so on and so on. Still not backslash 0, so I continue. So now it's 45. 45. What is at the address 45? H. What is 45 plus 1? 46. What is at the address 46? O. So now r equals r plus 1 because it's still not backslash 0. So O, 47. Another O. So now it's 47. This address is an O. Then plus 1 is 48. Then it's a L. It's still not backslash 0, so I continue. So now R equals 48. What is the value stored at 48? The ASCII value of L. What is R plus 1? 49. What is stored at the address 49? Backslash 0. I have my backslash 0. I exit my while loop. At the end of my loop, R points to L, which is the last letter of my string. Does it make sense? Okay, so now we have solved the first element of our problem set. We have found the address of the last letter. The address of the last letter is stored in R, and it is 48. Okay? Awesome. So now let's go back to the terminal. Like the question is like, can I do this with a for loop? Yes, the entire thing can be done in a for loop like this. For r equals ptr, you set r, and then while r plus 1 is different from backslash 0, then you do r plus plus. And here inside you do nothing. Okay, I would recommend you to do this with the while loop first to better understand. Once you're more comfortable, you can use the for loop, but I would just, at the beginning, try to use like the simplest tools to better understand. So here you have like everything is decomposed. It's a little bit easier to understand. Okay, so this can be also written this way, same thing, right? And this, the condition, can also be written like this. No. There's another way to do it. You can do it with a for loop with an array also, or with the while loop with an array. And the way you would do it is by you do that, and then you do for ptr equals r, right? And then instead of using the pointer notation, you use the array notation and you're using I. And you move I instead of moving the pointer. That's also possible, right? So let's try to go through this example with I. Do you want to do this, or like we just like move forward with the exercise, with the task? Do you want me to go through like step by step what happens in memory with the for loop using an integer I? Or should we move on to the task, to the next step? I think we have a huge delay. Step by step, move on. Okay, we move on, all right. Okay, so now we have our 2 pointers. The one that points to the first one, the one that points to the other one, to the last letter, okay? So going back to our whiteboard, we have the first letter, we have the last letter. Connection restored, let's go. Yeah, you can also do r plus equal 1. That works too. It's not working. Sorry, my whiteboard is lagging. Okay, it should be working now. No? Come on. Okay, the whiteboard not working. Sorry, guys. Come on. Okay, otherwise I'm going to just use the memory here. Okay, so at the end of my loop, or equals 48, right? It points to the last letter of the string. Now what we want to do is we want to swap those two. So same idea as the int swap. We're just going to swap 2 characters. So we're going to have like a third temporary variable to be able to store the value of the one character that we're going to replace first. Okay, so if we want to start with replacing this one, we're going to store this value of this one somewhere else so that we can store L at the address 40 and then find the M here to save it into the address 48. So let's just say we're going to have to use like a variable of type char. Let's call it C. we could call it TMP because it's kind of temporary. And this is going to be of type char. We're going to declare it this way, basically, char TMP. When we're going to declare it, it's going to be unknown, the value of char TMP, but then we're going to use the pointer PTR to get the value where it points to, put it into TMP, then use the address stored in R to copy this into the value stored in PTR. So take L and store it in M, and then take this TMP and put this value back to 48. And then we're going to have swapped the first two letters. Okay? So the way we're going to do this is we want to store into the address PTR, which is stored in PTR. So what is stored at the address PTR, you put what is stored at the address R. Okay? So at this stage, first we're going to do TMP equals PTR, right? So at this stage, TMP equals PTR, you're going to store M, okay? So you go at the address PTR, you take what is stored over there, it's M, and you put it into TMP, okay? Then you put what is stored at the address R, so at the address 48, and you put it where this pointer PTR points to, so at the address 40. So at this stage, it looks like this. And now you're going to do what is at the address R, you're going to store what is the value of TMP. And then at this stage, this is going to be this way. Okay? So this is basically my code. So let's go back to the terminal. So this is the action of swapping. Okay? If I print my string right now, right, just to make sure that everything works properly, if I print my string right now, it should print lyscum, right? And we should probably test it right away. So let's do that. Let's go back to the terminal. Up. And I'm going to print this. Okay, and then GCC 5 main and 5 web string. TMP undeclared. I forgot to declare my variable TMP. So it's of type char. Okay, and now, so this is my school in the main function, and this is from the ref string function, and we actually had changed the string. So when you go back to the main file, to the main function, it's still the same as the one that was in ref string. Okay, so this is working. So now what I need to do, I need to move my 2 pointers by 1 byte towards each other, right? So now I want to point to Y for the first pointer, and I want to point to O for the second pointer. So the first pointer is PTR. What I need to do is just like do PTR plus 1, and then I'm going to point to the Y, because then it's going to be 41. And then R, I want to do like R minus 1, so then it's going to be 47, and then it's going to point to O. Okay, and then I swap again. So so what I want to do is I want to do PTR equals PTR plus 1, okay, and R equals R minus 1. So at this stage, if I do this, now if I go back to my memory, if I do if I do PTR equals PTR plus 1, then PTR is going to equal now 41, because it's 40. So now it's 41. And if I do R equals R minus 1, then R equals now 47, because it's 48 now. Okay? So now R points to O, and PTR points to Y. And now I need to do the same thing again. Swap again. Okay? So I'm going back to my terminal. And basically I need to swap again. I need to do this again. Okay? And then I'm going to do the same thing again. I'm going to move PTR to the left and R to the right. So I'm going to do this again, and then this again. So it sounds like a loop, right? So it's going to be a loop. While something, I'm going to do this. Until it's over. And how do I know it's over? How do I know that I need to stop moving my pointers and swapping the letters? What is going to be the test in my while condition statement? Anyone? Anyone has an idea? What is going to be my condition to stop the loop? When do I need to stop to move the pointers and stop swapping the letters? When you reach the null terminator. Interesting. Null byte. Okay, so let's try that. So you want to move basically the first pointer, when the PTR, when it hits the \0, then you stop, right? So let's try to see what it does. So when PTR is not 0. So that's your condition. So let's do this and see how it goes. So this is before I call the function, and this is after I call the function, and these are exactly the same strings. So if my condition is like while what is at the address PTR is not \0, I have like another one, when R equals PTR. Interesting. Okay, so let's see what's happening here, just to make sure everybody understands. So Vivian, first, you're gonna have to dereference PTR, right? So if you want to like check it against \0, it's gonna have to be a char. Can't be a pointer. But what's happening here? Let's do it step by step in memory. I'm gonna do like PTR here and R here, okay? And then I do +1 and -1 basically. So I restart from scratch. I'm not gonna do it to the swapping. Now we know how to swap, right? But I'm just gonna swap them as we go. So R first is 48, and then PTR first is 40. Okay, so and your condition is like PTR hitting \0 if that's your condition. So PTR first, PTR is 40, okay? Then it's R. R is 48. So this is M and this is L, okay? So all right, this is not \0, I swap. So boom, I swap here, I swap here. So now I do PTR++, so now PTR equals 41, and now R equals 47, okay? So now this points to Y, and this points to O. Okay, this is not \0, I swap them. So now this is O, and now this is Y. Okay, not \0, I continue, 42, 46, and then I point to space, and I point to, so this is space, and this is O. Okay, continue, I swap them. So this is gonna be O, this is gonna be space, and then I continue. So this is 43, and this is 45. So 43, at the address you have S, and here at 45 you have H. So you go ahead, you swap them. So this is H, this is S, and then same thing, 44, 44, this is a C, this is a C, this is the same thing. Still you swap them, so it's like C, but then you continue, right? So this is now 45, and now 43, at 45 right now is S, and at 43 right now is H. So then you swap those two, H and S, okay? You continue, 46, 42, 42, no, sorry, 46 and 42. At 46 you have space, and at 42 you have 0, so you swap space and 0 and O, sorry, and then you go ahead, still not \0, so you continue, 41, at the address 47 is Y, at the address 41 is O, so you swap them, so you have Y here, and you have O here, still not \0, you continue, so you have 48, and then you have 40, and then at 48 you have an M, and at 40 you have an L, you swap them, this is an M, it's an L, still not \0, so you continue, 49, and 39, okay, but at 49 now you have the \0, so you stop, right? And what happened really is that you reversed the string twice, right? And so really where you wanted to stop was there, right? Here. At this stage, you had reversed the string. So let me go back. So at this stage, 43, 45, S and H. Yeah, at this stage you had reversed the string. Okay, it's reversed more than once because you reverse it once, and when you're at the middle, here it's done, right? But if you continue after that, if you continue until the end of the string, you're going to reverse again. Okay, so the idea is here, you want to have PTR less than R. While this is true, while the pointer haven't crossed, if they cross or they're equal, you don't need a swap anymore, right? So while those two pointers, while PTR is smaller than R, then you continue. Sounds good? That's gonna be the right thing. And like A, it's not exactly equal to, because if you do equal to, you have 42, 42. And like here, like you have like the, you're gonna swap like the one in the middle, which are the same. You don't need to swap itself, the character by itself, right? What does that mean, Vivian? Check your 45 and 43 again. I'm not sure I understand. Oh, one very important thing. Why is it not, Nico? It can't be this condition. Because sometimes it depends on the number of letters. But if the number of letters are even, then they're always going to be different because they're going to cross. Hop, and at one point, they're never going to point to the same character, and then boom. So this will not work. If I take another example with one less letter or one more letter, the pointers R and PTR will never be the same. So if you have the condition that they are the same to stop, then you're never going to stop, ever. You're going to try to swap like the entire memory. Does it make sense, Nico? Okay, so I'm going to go back to the terminal and finish. No, so Theodore, like we just explained why you can't do that. You can, like, your condition cannot be that you're looking for the last character to swap, right? It cannot be that. So this one is wrong. But it's like, it's a good first instinct, right? But then you're gonna see that it doesn't change anything, and then you want to understand why. And again, you want to go step by step, right? Step by step, go through like what is happening step by step. It takes a little bit of time, much more time than like trying to code right away, but then you understand everything. So take this time to really understand, and you're gonna be able to debug stuff with pointers much more effectively if you do so. Okay, so in reality, like you want to have like PTR less than R. Okay, and this should work now. So Omitugan, you're saying while R is less than half the length of the char array. So R right now in our this is a good idea, but like not exactly the way you propose it. So one of the other idea would be, is my whiteboard working again? Yeah. One of the idea is you have your string, right? You just say like a, it's not working, come on, here. Okay. So hello. Oh, yeah. If you have like hello, for instance, the length of this string is 5, right? So while you have like, if you're using like a variable of type integer and you use it with the it's lagging a lot, and you use it like this, then you can like have like I, while I is less than len divided by 2. But then it means that you have to go through, you have to count everything while you're doing this. So it works well. It's just like using another variable that you don't actually need, but it works very well. What's the logic behind PTR less than R? So let me try to, can I do, it's going to be bigger? No. So we are having our letters. And we saw that to reverse everything, Ogeda, you have to have like a pointer to the first letter, a pointer to the last letter. We called our pointer to the first letter PTR. And then we called our pointer to the last letter R. Okay? And so basically, you have those two pointers and you swap those letters that they point to. And then you move PTR one step on the right and like or one step on the left, and then you swap those two new letters that they point to, and so on and so on. But if you swap them, once they cross, you're going to re-swap the entire string. So the step 1 after this is going to be you swap, and then you're going to have D, B, C, A. Okay, then you have like those pointers here, PTR and R. Then you swap again. Then you're gonna have D, C, B, and A. No, sorry, B, C. Yes, and A. Okay, and then here the string is reversed. So now if PTR, if you continue, and now you have like PTR here, and you have R here, and you swap again, okay, then you're gonna continue, and you're gonna have like B and C swapped. And then you continue, and then you have like R here and PTR here. And then you swap again, and then you have A, B, C, and D. And you effectively swapped twice the string. So the condition is that you have to stop when PTR crosses C. Okay? When the pointer moves, does it remain in the new position permanently? Yes. You should be seeing the part of the screens now. But we have like a a huge delay. Okay, cool. Okay, so you swap all the letters, and once you hit the middle with both two, you have swapped all the letters. Because like the 2 pointers went through all the letters themselves. If you do it again, then you're gonna reswap to the original string. How do I learn to write clean code? But like you just do the same. You whiteboard and you go through the memory template for pointers at the very beginning. You do things like very, step by step. I check my code like step by step. I didn't try to do everything at once. I try to rephrase the exercise. Then I went through different examples. Then I went through the whiteboard, try to find like what I need. And then and only then I started to code step by step. And I didn't code everything at once. Okay? The video is not going to be available. I can do like other live sessions later if you want, guys. But I want to make sure that everybody focuses on this. And I don't want anybody to, just like copy and paste my code. This would be very, very bad. So I don't want like anything like this. Okay? All right, guys. So you have my Twitter account. If you have any question, just like tweet at me. And I'll see you around. I hope you got some value out of this. Have a good night, everyone.